Good evening and welcome to lesson 11-1 on the square roots and irrational numbers. In tonight's lesson, you're going to be able to find the square roots of numbers, and you're also going to be able to classify numbers as either rational and irrational. So we're going to go ahead and get started. And we're going to skip the warm-up and go right to the first part of the lesson, which is finding square roots. Now, I have squares off to the side, and in fact, I kind of screwed up on that one. That should say 3. But what we know about squares are that each side is the same length. So when we talk about the area of a square, what you really just do is multiply the length by itself, or you square the length. So here, if the side is 1, well, we do 1 squared and we get 1. 2 squared is 4, 3 squared is 9, and so on. So what we end up with is this idea of a perfect square. That is where you square the integer to get this 1, 4, or 9. They're considered perfect squares because, again, you were just able to square or multiply the number by itself. All right, the opposite or inverse of that is called the square root. So instead of telling us the length of the side like they did here, telling us the length was 1, what they end up doing is saying, well, the length is something here, but the whole area is 16. So you're left to figure out what number is being squared. And here, you're undoing it. So what number can I square to get 16? Well, that would be 4. 4 times 4 is 16. So here, they have talked to us about simplifying each square root. And I should probably say one thing before we move on. All right, going back to this last example, there is another number you can square to get 16. Because if you do -4 squared, well, 2 negatives make a positive. All right, so in fact, a -4 and a 4 would actually be an answer to the idea of 16. But in our textbook, if there's no negative on the outside, they want you to just give the positive square root. So for example, we'll do 8. The square root of 64. Well, what number squared gives me that? That would be 8. 8 squared is 64. B, it says the negative or the opposite of the square root of 10. Well, the square root of 100. Well, the square root of 100 is 10, but they want the opposite of it. So here our answer is -10. All right, you go ahead and do C and D very quickly here. I'm not even going to pause the video, but just go ahead and do it, and in about 5 seconds, I'm going to give you the answer. So go ahead and start C and D now. All right, so looking at C, what number can I multiply by itself or square to get 144? Well, that would be 12. And then here, D, the opposite of the square root of 81. Well, 9 squared gives me 81, but they want the opposite. So I should have -9. Okay, we can also estimate square roots because sometimes they don't give us nice whole numbers to use. All right, so we could list the first 13 perfect squares here. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 49, 64. Next would come 9 times 9. Wow, that is not good. 9 times 9 is 81, 10, 100. 11 squared is 121, 12 squared is 144. There we go. So those are the perfect squares, and it might be a good idea to have those memorized just because it'll make it easier as we go through these lessons. All right, so here they give us this example, the square root of 8. They want us to estimate about what is that. All right, so looking at it, we can just do, well, the 2 squared, I know is 4, 3 squared is 9, and 4 squared is 16. Right? So I need to figure out where would the square root of 8 go. Well, looking at it, it's not between 9 and 16, so that part's out. It is between this 2 squared and 3 squared, though. But taking a look at it, so it would be right, really closer to 9. Square root of 8 would be right before the square root of 9, which is 3 squared. Here, square root of 4 would be 2, and so on. So if we were to estimate the square root of 8, we would say that it's approximately 3 because it's much closer to the 3 than the 2. All right, so there's that piece. Now we have this example. You can use a formula. D is equal to the square root of 1 5/10 times h to estimate the distance d in miles to a horizon line where your eyes are h feet above the ground. Estimate the distance to the horizon horizon seen by a lifeguard whose eyes are 20 feet above the ground. So here they're making us do a little bit of work inside the square root, and then they're also using the word estimate. So this is where the idea comes in from last time. So I'm going to go ahead and write the formula down here. 1 5/10 times h. All right, distance d in miles, you can see h is how many feet you are above the ground. So estimate the distance to the horizon seen by a lifeguard whose eyes are 20 feet above. So they're giving me h here. So 1 5/10 times 20 is going to equal d. Now, we need to simplify this first. So first thing we want to do is multiply 1 5/10 times 20. So 1 5/10 times 20 is 30. So we need to decide, where does the square root of 30 belong? Between what two square numbers? So again, I could think, well, I know 5 squared is 25, and 6 squared is 36. So I need to decide, what is 30 closer to, 25 or 36? And looking at it, it's actually a little bit closer to 5. So here it would be about 5 miles away. Just because it's only 5 away from 5, or 30 is only 5 away from 25, while it's 6 away from 36. That's why I went with 5. All right, so that's the first half of our lesson. Next, we're going to talk about how we can classify real numbers. When we talk about real numbers, we separate them into 2 categories. They're either rational or irrational. Now, when you talk about rational numbers, it's a number that can be written as a ratio, meaning it can be written as a fraction. All right, so this includes like whole numbers, because if you have the number 2, well, to change it to a fraction, you put it over 1. It includes fractions, so if it's already a fraction, or 3 1/2 can be switched to an improper fraction to be 7 halves, and so on. It also includes terminating decimals. Again, terminating decimals are those decimals that stop, like 3 2/10. And again, it's considered rational because you can switch it to a fraction. We have a whole number 3 and then 2/10, or simplified to 1/5. Or any repeating decimal. So for example, 0.3333 repeating. Because again, if they're repeating, usually they turn into a fraction. Like in this case, it turns into 1/3. Right? So any number that can be written as a fraction without 0 on the bottom is considered rational. Irrational is the opposite. These are numbers that cannot be written as a fraction or as a ratio. And this includes decimals that are neither terminating or repeating. So if these decimals keep going on and on and on, and there doesn't seem to be any repeating to them. So it doesn't go like 0.333 or 0.21212121 and so on. They're considered neither terminating or repeating. They're irrational. An example of this would be like pi, because there's really no real pattern going on. It goes 3.1415926 and so on. So it doesn't repeat. So now we have to determine where each one lies. And you'll notice they have some square roots in here. So I think we're going to do a couple of these together, and then I'm going to leave you to do the others. So A, well, the square root of 49, well, that changes to 7. And 7 would be considered rational, because if you write it as 7 over 1. If we skip to C now, 1600ths, well, this is a terminating decimal. Well, if it terminates, it's considered rational. And again, you can figure this out by seeing if you can write it as a fraction. 1600ths, well, that'd be 16 over 100. All right, E, we have the square root of, or the opposite of the square root of 15. And you could put these into your calculator as well, but you end up with negative 3.872983346 ongoing. Well, looking at this, it doesn't repeat, it doesn't stop, so it'd be considered irrational. All right, and finally we'll do G together. We have 0.1234567 going on. Now this one can be tricky because you could say, oh, I see a pattern, you're just going up by ones. But it's not repeating. So in this situation, because it's not repeating, it is considered irrational. There we go. We did 4 of these together. Now I want you to do B, D, and F. And when you're all done, come back and check your answer. So you can go ahead and pause me now. All right, let's check these, shall we? So the square root of 20, if you go ahead and do that one, you end up with about 4.472135955, so on. Looking at it, it doesn't stop, it doesn't repeat, so it is considered irrational. All right, and then looking at this one, we have D, 0.3333. So it's repeating. Because it's repeating, and I know that would actually be 1/3 as a fraction. So go like that. And then we have 12 and 69/100. Well, this terminates. So you should have rational written down. All right, so again, when you're doing these ones, just make sure you check it to see if they stop, the decimals terminate, or if they repeat or so on, because those are the trickiest parts, I think. All right, so that's your lesson for tonight. Tonight we talked about how to find the square roots, how to estimate the square roots, and finally classifying irrational numbers. Have a good night. I will see you in class.